Hello everybody, hope you're doing well and thanks for joining us for another video. Today I want to tackle what is probably one of the most common remarks made by flat earthers, certainly in the past year or so, where they say, lights in the sky don't tell you the shape of the ground. This is referring to celestial objects like stars, the moon and the sun, and they say you can't determine the shape of the earth by looking at the sky in the same way you wouldn't have a carpet fitter measure your floor by looking at the ceiling. Now, this statement has become a whole lot more popular amongst flat earthers in the last 18 months or so since our trip to Antarctica to record the 24-hour southern sun. Basically as a way to dismiss that evidence because it points to the Earth being a globe. It's funny because they say now, lights in the sky can't tell you the shape of the ground. But a few months ago, Flat Earth Dave was putting up on social media posts about the GoFast rocket launch being able to see the moon as proof that the Earth is flat.
When it turned on its side, all of a sudden you can see the moon. This little dot right here, that's the moon, right? Horizon's looking a little flat, right? But then if we go to timeanddate.com, when this was taken off, well, it took off right here, and the moon was over Australia.
2 years ago, Taboo Conspiracy published 3 videos called How a Pilot Ended the Globe, which was all based around what stars were visible during a time-lapse from the cockpit of a plane during a flight. And 10 years ago, Flat Earther D. Marble travelled to northern Alaska to record the 24-hour northern sun, and there were flat earthers back then who used that as apparent proof that the Earth was flat.
Well, hang on, 24-hour sun, explain that on your model. Explain that 24-hour sun. Tell me how that works on your ball.
Well, why don't you answer my question first?
Well, no, because we're actually looking at the 24-hour sun.
Yeah, because it's on screen right now, and someone's gone twice to
This was
to
on
get it.
first.
So really for flat earthers, it's actually more a case of the lights in the sky don't tell you the shape of the ground when it points to the Earth being a globe, but when they get the data wrong and they think it points to the Earth being flat, then it's perfectly acceptable. Now, regards the 24-hour sun in Antarctica proving a globe, many people have asked, how does it prove a globe? Or saying, surely that could work on a flat Earth. And as a single data point, a 24-hour sun in Antarctica doesn't actually prove anything because you could use an AE map with Antarctica in the middle and the sun looping around it, and that would work. The problem is you can't just take individual data points and make a conclusion for each one. I.e., a 24-hour Antarctic sun requires Antarctica to be at the center of a map. But the 24-hour northern sun that D. Marble captured would require the Arctic to be at the center. Or you'll have flat earthers say that what we witnessed in Antarctica could be caused by the sun reflecting within the firmament, but then they'll also show photos of the sun below an aeroplane and claim it proves the sun is local and in the clouds. Or that at sunsets it's just the sun moving away to a point. Well, unless planes fly beyond the firmament, then those are two very different locations that the sun would have to be at the same time. Hence, they then have to default to, oh, lights in the sky doesn't tell you the shape of the ground, and that is where their problem lies. They have no unified model that can explain everything. So when you then break things down into smaller sections, they need a different explanation for how each piece works. But then all the pieces can't fit together. When you learn a new subject, you cover small topics at a time, but at the end, all of those pieces can come back together and they all fit with each other perfectly. Just like today's sponsor, Brilliant.org. Brilliant is one of the most effective and engaging ways to learn online. All their courses are split up into bite-sized classes, starting with the basics and building up gradually. And you can jump ahead at any point you like, so you can learn at your own pace, regardless of whether you're new to a topic or if you're already familiar with it. I find the classes very engaging thanks to their interactive animations, which makes it much easier to visualize the topic. They have courses across all manner of maths, science and computing to keep you occupied for weeks. And thanks to the app, you can learn while you're on the go. Even just a few minutes a day will help keep your brain healthy and active. I've been a long-time user of Brilliant now, with the daily streak of completing lessons now surpassing 1,070 consecutive days. But don't just take my word for it. Go to brilliant.org/Dave McKeegan and you can not only get yourself a 30-day trial completely free, but if you choose to continue afterwards, you'll also get 20% off their annual subscription. So check them out today. So, to flat earthers, lights in the sky can tell you the shape of the ground when they think it's telling you the ground is flat. But in this video, I want to lay out how you can tell the Earth is a globe based on the lights in the sky. The most damning and easiest way for anybody to destroy flat Earth in all but 5 minutes is to use Stellarium, which is a totally free website and app where you can plug in any location on Earth, a time and a date, and it will show you the exact positions of what stars, planets, sun and moon you'll be able to see from that location. Thousands of people use Stellarium to plan viewing and photographing the night sky every day, like knowing what planets will be in view, or when a particular constellation will be visible, or even if the moon will be getting in the way and what phase it will be up to. Anybody can verify the accuracy of Stellarium simply by looking at what stars will be visible from your location at a particular time and date, then going outside and checking for yourself, and you'll find they match. Now, there is a very basic principle to bear in mind with all of this, which is you cannot transform one shape into a different shape without distorting things. Hence, you get distortions in distances between an AE map versus a globe, because as you unfold the sphere into a circle, it stretches some parts and squashes others. Which is very important to bear in mind here with Stellarium, and the fact that the stars appear in the sky in Stellarium exactly where they appear in reality for that location. Because along the bottom of the screen are various filter options, like labeling or showing constellations and galaxies, and there's an option to toggle the atmosphere on and off, which basically increases the contrast of the night sky, and then it doesn't hide stars during the day. It doesn't go and drastically change the location of the stars. You can see them track the same paths over a 24-hour period, regardless of if the atmosphere is on or off. Though one interesting thing to note is that stars near the horizon shift slightly when toggling atmosphere. With atmosphere on, the stars are lifted slightly higher because of refraction. For example, Beta Hydra here is sitting at 1 degree 44 minutes elevation with the atmosphere on, but drops to 1 degree 24 minutes with the atmosphere off. But stars at higher elevations see much smaller shifts in star positions. This is actually why it's recommended to avoid using stars near the horizon for readings when doing celestial navigation, because their apparent position will be different to their actual position, which can lead you to get an inaccurate location fix. However, the more interesting overlay for Stellarium is the one next to atmosphere, landscape. Toggle this off and it removes the ground, so all you can see are stars. And the stars are under the ground, and the fact that Stellarium is actually using a globe and a celestial sphere for its star positions. And the important part for this, for flat earthers to remember, is that the layout of the night sky has been known for centuries. All these stars are verifiable in terms of their relationship to the other stars. So if the Earth were flat, then the celestial sphere wouldn't actually be a sphere. It would be a hemisphere at best, which means all of the stars in Stellarium would have had to have been stretched twice as far as they should be, so they shouldn't match reality. Yet they do. I mean, you don't even need to turn off landscape. You could just zoom out and look straight down at the ground. It goes semi-transparent anyway. And what I particularly like doing is holding down the minute button and watching the whole day play out. You can literally see Earth's rotation as the day goes by. It might not be the most obvious at latitudes around 40 to 50 degrees, but if you go right up to high latitudes like the top of Greenland, click on the sun and lock it into view and then play the day through, you can see Earth's rotation. Though sure, some flat earthers will say that, well, you get the same on a flat Earth in Greenland where the night sky circles above the North Pole. However, if you go near the equator, look down with north at the top of the screen and then play through, that is the lights in the sky following the path for a rotating globe, and they perfectly match reality. But it's not just the stars and sun. We have planets. One thing I like to see with Stellarium is to slide the time of day to where the sun is just below the horizon, and then run through day by day so it stays at the same time of day with the sun just below the horizon, but you can see the orbits of the planets, such as when Mercury or Venus would be visible. You can do this for different locations and noticing differences in their paths depending on latitude. Near the equator, you see Mercury and Venus looping up and over the sun, because on a globe at the equator, you're essentially sideways compared to people standing at the poles, but then you look at high latitudes like northern Canada or southern Chile, and you can see that even during the same dates, the paths of Mercury and Venus that people will see them take are tilted and mirrored to each other. Now, sure, flat earthers might say, oh, well, you can't verify that because we can't turn the ground off and the atmosphere off, and during the day you can't see any of this. So let's instead look at orbits during the night, when everybody can see them. And I think Jupiter is one of the best examples, because not only does Jupiter stand out as a very bright star in the night sky, but with a telescope you can make out its 4 main moons, Io, Europa, Ganymede, and Callisto. And these have pretty quick orbit times. Io orbits less than 2 days, Europa in just over 3, Ganymede in about 7, and Callisto in 17. So quite frequently you will see 3 or even 4 moons visible on the same side of Jupiter, which basically acts like an arrow in the sky. Now, just for reference, this is actually a photograph of Jupiter and its 4 moons that I captured way back in 2013. Though I realise it's not the best quality photo. So last night I had a look on Stellarium and noted that Jupiter would be visible from my location, and that it would be 3 moons on one side, one just above the other, and then the 4th moon way off on the other side. So I quickly went out just with my 500mm lens on my camera and was able to capture this, just to highlight how much Stellarium does actually match reality. So people at various latitudes along a similar line of longitude could all view Jupiter at the same time and compare where the moons appear in relation to Jupiter. Here are a few examples I grabbed for March 6, 2026. For people in very northern Canada, the moons line up straight to the right of Jupiter in the 3 o'clock position. To people in Winnipeg, they point more between 4 and 5 o'clock. In Mexico, it's closer to 6 o'clock. In Lima, it's past 6 o'clock. Way down south, it's closer to 8 o'clock. In fact, I took a series of shots from multiple latitudes running down the Americas, and here they are as a sequence. Now, bear in mind, all of these are set to the exact same moment in time, but the moons of Jupiter are rotating like the hand of a clock, based solely on latitude. And of course, it's not just Jupiter. We can see the same thing with the face of the moon being a different orientation depending on latitude. In fact, the entire sky changes orientation. This is the night sky from northern Norway on March 2nd at 7:45 p.m. We have Jupiter, Procyon, Sirius, and Betelgeuse forming a diamond with Jupiter at the top. Capella is up and to the right. The moon is to the left of the diamond, whilst the Pleiades cluster is to the right. But from South Africa, at the exact same moment in time, the diamond shape now has Jupiter at the bottom, Capella is down and left, the moon is on the right, and the Pleiades is on the left. And viewed from the equator at the same time, the whole thing is twisted partway round. And we saw the same thing in Antarctica with the sun, which is actually a key part of TFE that flat earthers don't like to talk about. I took photographs of the sun every minute for more than 24 hours with a solar filter on so that the sunspots were clearly visible, and the spots remained in the same orientation for the entire period of time, which shows that from our position the orientation of the sun wasn't changing. However, at the same time, there were people all around the world capturing the sunspots, and even though we saw the same sunspot patterns, the orientations that people were seeing was different depending on their latitude. They were never flipped or mirrored like a reflection that some flat earthers claim, simply rotated, as we would expect with changing the orientation of the observer. But even just staying around the same latitudes, we can see from the lights in the sky that the Earth is a globe, simply viewing the stars and how they drop to the horizon. Even flat earthers will acknowledge 1 degree per 69 miles, which is that for every 69 miles you travel, things drop by 1 degree. For example, I've just pulled up Stellarium here, and at midday on March 2nd, at a location in central London, the sun is at 31 degrees 22 minutes elevation, pretty much directly south. If I pull up Google Maps, I can measure out 69 miles to the north, which puts us near Ramsey. If I then move our location in Stellarium to there, we can see the sun elevation has dropped to 30 degrees 22 minutes. So pretty much exactly 1 degree drop for 69 miles moved. And we get the same thing east to west as well. If you had two people directly east or west of each other 69 miles apart, when the easternmost person saw the sun perfectly touch the horizon, to the western observer, the sun would be 1 degree above the horizon. Now, we get this figure of 69 miles per 1 degree from the globe having a circumference of 24,901 miles and there being 360 degrees in one full circle. So each 1 degree of a circle has a circumference of around 69.1 miles. And the important thing here is it is consistent. It doesn't matter where you are in the world, it is always 69 miles per 1 degree. If you're on the Tropic of Capricorn during the December solstice, when the sun is pretty much directly overhead and you move 69 miles, the sun moves 1 degree. If at that exact same moment in time you had someone in Ottawa, Canada, and they moved 69 miles north, the sun would still move 1 degree. If the Earth were flat with the sky circling above us, then the amount of movement would increase when they were closest to us and slow down as they got further away. Then you've got things like meteor showers. Now, to some people, meteor showers might just be pretty lights in the sky that seem to happen at random. But meteor showers themselves are actually very consistent, quite common, and very predictable. Astrophotographers plan ahead. They know when a meteor shower is going to be occurring, where best to view it, and where the meteors will be originating from. They don't just turn up at random in the sky, they actually come from certain regions of the sky. Usually the meteor showers are named after the constellation in the sky where they appear to be coming from. Now, this happens on a globe when the Earth reaches certain points in its orbit around the Sun and it's passing through the leftover remnants of a comet's tail. So then, depending on where the Earth is in relation to the Sun, will impact what constellation appears to be in the same direction as where the meteors are originating from. Well, that's the explanation for the globe. Flat Earthers don't really have an explanation. One, for why meteors turn up in the first place, where are these rocks coming from without breaking the firmament, but also why and how are they so predictable in where they will be originating from and exactly when they will be happening. No matter how much flat earthers say you can't tell the shape of the ground by looking at the sky, you absolutely can. If you were in a car at night, driving down a pitch black road with all the lights off, please don't actually go and try this, all you could see would be the stars. So that's your only reference. If the stars were staying in the same place in your vision, you knew you were driving on a straight piece of road. However, if the stars then begin slowly drifting down, you would know the road was rising up, even though you can't see the road. And if the stars start climbing, then you know you're going over the crest of a hill and the road is starting to curve down. And if somebody was looking out of the rear window as they went over that crest, then the stars would appear to drop down. And on Earth, if we travel fast enough, like on a plane, the stars in front of us will rise up and the stars behind us will drop down, behaving exactly the same as though we're going over the crest of a hill, which points to either Earth curving, like the crest of a hill, or hills are flat. Oh God, that's going to be the next conspiracy, isn't it? Well, that's going to be it for this video. As always, feel free to leave your thoughts in the comments down below. If you enjoyed this video and you haven't already done so, then please do consider hitting the like and subscribe buttons, and hopefully we'll see you in the next video.